All right, so this last one is end behavior. So end behavior is just what it sounds like, what's happening at the ends of the graph. So on the right side and left side, at the very ends of the graph, which direction is the graph going? Is it going up or is it going down? That's what we're asking ourselves. So we have we can answer these questions. Sometimes you can have, your answers can look a few different ways. We're going to use what's called limit notation to answer all of these. So at the top of your paper, and kind of gives the definition of end behavior, and then it shows what the answer is going to look like. So let's just read the end behavior and then we'll do the problem. So the end behavior describes the behavior at the end of the graph as the x value approaches positive and negative infinity. As the x value of the graph continues to positive or negative infinity, what is the y value doing? So it's basically saying the left and right side, on the left side, on the right side, is the graph pointing up or is the graph pointing down? That's all you have to tell. So on the right side, is it pointing up or down? On the left side, is it pointing up or down? Then we have to write our answer correctly. So you've got to be careful. This is called limit notation. Okay, that's limit notation, just limit notation, just a way that it's written. That's what that word means. So what you're going to have for every answer is you're going to write the limit of f of x. F of x represents the equation. So like if we knew what the equation was, that would go there where the f of x is, but we don't have these equations. We're just going to write f of x. And this side is what our actual answer is going to be, but you have to write out the entire limit and put the answer on the right side of it. The other thing that's going to change, so this part, I'm just kind of show you this piece right here, the limit and the f of x, this will be the same every single time. The pieces that you're going to change is you're going to change this part and you're going to change this part. The bottom piece has x going to positive infinity. You're going to have two things. You're going to have one going to positive infinity, one going to negative, which means it tells you if you're going on the right or left. The left side is negative, the right side is positive. So you have one positive, one negative, and then this side is also just going to have a positive or negative. Let me just show you. It'll make more sense when you see it. So let's do the very first thing you're going to do. There are two ends of this graph. So that's why it has end behavior twice, because you have a right end and you have a left end. So we're going to have an end behavior on the right side and on the left side. So the first thing you're going to do is you're going to write the limit of f of x equals, on both of these, that part is going to be the same on every single problem. That will not change. Then you're going to have as x approaches positive infinity and x approaches negative infinity. So x, and then you have an arrow and a positive infinity. Then on the bottom, we're going to do x approaches negative infinity. That is going to be the same on every problem. You're going to have one positive infinity, one negative infinity. The right side will change every time. Sometimes they'll both be positive, sometimes they'll both be negative, sometimes you'll have one of each. But this part that I've written so far is going to be the same on every single problem. So I want you to go through and write that exact same thing on every problem, and then we'll go back through and do all the answers. So just write that exact same thing, 1 through 6, on all of them. Okay, so that's the longest part of just writing all that stuff down. So let's go back to number one. So on number one, we're going to do the same process on all of these. When it has the bottom piece, so we have one that has x approaches positive infinity, one that's x approaches negative infinity. So this one right here, when it's at positive infinity, that's going to be the right side of my graph. And this one, when it's negative, that's the left side of my graph. Okay, so the positive is the right side, negative is the left side. So you know this is talking about right and left, and you should know right's positive because that's the positive numbers, left is negative. So when it has a positive infinity at the x part, the x approaches positive infinity. So this piece right here is the right side of my graph. So I'm looking at the right side of my graph, and I'm saying, is the graph pointing up or down? So which way is it pointing, up or down? Up. So the answer, it's pointing up, which we know up is positive. So the answer is just positive infinity, and that's it. So for the second one, this is where x is negative infinity. That is the left side of my graph. So on the left side of my graph, is the arrow pointing up or down? Up. So it's going to also be positive infinity. And that's it. That's your answer. You do have to write all of that to show that's your answer, because the x approaches infinity that I have highlighted in yellow should go with that. Those two things kind of line up with each other. They're not always the same, but the positive infinity side goes with the right side. The negative goes with the negative. So let's do number two. So first we have x approaches positive infinity, which is the right side of my graph. So on the right side, which direction is the graph pointing? Down. So I'm going to do negative infinity for my answer. So if it's pointing up or down, that determines if it's positive or negative. On the right side, or the other side, the negative side, the graph is also pointing down. So I'm going to have negative infinity. So they're both negative infinities on those answers. Okay, number three. So the first part, this says positive infinity, which is the right side of my graph. The right side is pointing up. So the answer is going to be positive infinity. Then the other one, I have x approaches negative infinity, which is the left side of my graph. The graph is pointing up. So it's going to positive infinity. Okay, number four. Again, the first part is the right side of my graph. The right side is pointing down, so it's going to go to negative infinity. And then the x goes to negative infinity is the left side of my graph. It is also pointing down, so it goes to negative infinity also. So now let's look at number five. This one's pointing opposite directions. So we have to be careful here that you match the right things up. So this x approaches positive infinity. That's the right side of the graph. So that bottom piece is positive. That means it's the right side. So the right side, is it pointing up or down? It's going up. So this is going to be positive infinity because it's pointing up. Now the second one, this is on the negative side. So the left side of the graph, and the left side is pointing down. So that answer is going to be negative infinity. So one of those is positive, one's negative on that one. So let's do number six. The right side. So the right side is when x approaches positive infinity, and this one it is pointing up. So this is positive infinity. And then when x goes to negative infinity, it's pointing down. So it goes to negative infinity. They don't always match up. It just depends on which way the graph is pointing. Also, please make it very clear if it's a negative sign or if it's a positive infinity. So don't make your negative look like an accident. So I can really tell that it's negative. So make sure it's really clear that it's a negative or a positive infinity on those. Any questions? Okay.